Today I'm going to introduce you to some vocabulary we use in order to graph trig functions, and I'm also going to introduce how to write equations when you look at a trig graph. So the first vocab word we have is the amplitude. What the amplitude is, it's how high and low the function goes. A good example is if I'm looking at this picture here, I see that the height of my function is 3 and down to -3. So I would say the amplitude here is 3. Okay, the way we find amplitude is you take half of the highest value in the picture minus the lowest value. So if I look at this next graph here, my highest value is 4. My lowest value is -2. 4 minus -2 is 6. The amplitude is half of that, so half of 6 is 3. Notice that the amplitude will always be positive. I also want you to notice something else. Look at these equations. Do you see how there's a 3 in front of this function, 3 sine x, and the amplitude was a 3? See how, again, the amplitude is a 3, and there's a 3 in front of the sine x? The number in front of the sine or a cosine will always be the amplitude. However, it will always be positive as well. And I apologize, your notes look better than mine. It just did not transfer over well to this program. So it says, note, while vertical shifts alter the max and min values, they do not alter the amplitude. Also, horizontal shifts do not affect the amplitude. And what they're talking about there is this example right here. Even though I move the graph up a little bit, the amplitude is still 3, even though it hit a maximum height of 4. Period is another vocab word we're going to look at. Period is how long it takes to see one complete cycle. For a sine graph, one complete cycle is this S curve right here. And I do my best to draw over it. And that blue S curve I just drew, that's one complete cycle. And I see it took a length of 2 pi to get there. From this point to this point on the x-axis is a distance of 2 pi. And that's what this thing says right here, that little paragraph. So it says a periodic function is an oscillating, wave-like function which repeats the pattern of y values at regular intervals. One complete repetition is called a cycle. The period of a function is the length it takes to complete the cycle. In functional notation, we could say the period is the smallest value of k in a function f for which there exists some k constant, such that for every number t in the domain of f. I would not worry about understanding this piece of it. We do not have to worry about that for this course. Just understand what a cycle is and be able to figure out how long it takes to complete one cycle. Another term we have is frequency. The frequency of a trig function is the number of cycles it completes in a given interval. Usually we look at from 0 to 2 pi. So if I look at this picture here, I'm going to draw the cycles. The black is one cycle. The blue is another cycle. So I can see that I have 2 cycles in that picture. However, if I only care about 0 to 2 pi, it's only from here to here, I only see 1 cycle. So the frequency we would say is 1. The last thing we're going to look at today is a horizontal shift. A horizontal shift will move a function over. Now the red graph is your normal sine curve. It starts at 0, goes up to 1, down to -1, and back up to 2 pi. Your blue curve is moved over a little bit. Instead of starting at 0 like it does here, it's over here instead where it hits the x-axis. Well, that moved a distance of pi over 4. I always look to see where it starts versus where it should have started. So this moved right a distance of pi over 4. the way we write that in an equation is that minus pi over 4 in parentheses. What I'm going to do is, instead of graphing all of these, and I'm sorry again it came out poorly, I'm going to show you how to look at an equation and be able to find amplitude, period, frequency, and phase shift. So the first one we have, and I'll use different colors to help us here. The first one we have is y equals sine theta, and I'm going to fill it in this spot here. For y equals, let me see how yours is set up, the 2 sine 3x minus pi over 4. I'm going to fill in for the amplitude, period, frequency, and phase shift piece there. And for the negative 5 cos 1/3 x, I'll have you guys try that one on your own since it's not going to work well in my picture anyway. So if y equals sine theta, the first thing I look for is the number in front of sine. The number in front of sine is 1. That's my amplitude. Then I look at the number in front of the variable, in this case the theta. The number in front of the variable is going to be my frequency. So that's a 1. My period is the formula 2 pi over b. The b value is the number in front of that theta, so it's a 1. 2 pi over 1 is 2 pi. And finally, for the phase shift, since there is no plus or minus after the x, as there is in the blue one that I'm going to do in a second, there is no phase shift, so I write none. To practice again with the one in blue, the number in front of the sine is a 2, so that's my amplitude. The number in front of the x is a 3. That's my frequency. Period is 2 pi divided by the number in front of x, so 2 pi over 3. And my phase shift is minus 4. Minus means move it to the left. And you move it left. Minus means move it to the right. And you move it right, whatever this piece is right here. Right a distance of 4. If it were a plus sign in parentheses instead, it would be left 4. So plus means move left, minus means move right. And I'm going to have you guys try the one in black later. The other piece I'm going to look at today is determine the equation for the graph as a sine and a cosine function. So if I look at my purple equation first, since I don't start at 0, 0, I start at the amplitude or the highest point instead. This is more of a cosine graph, and you'll get used to deciding in the future. So this graph again is more of a cosine graph. The amplitude, it gets up to 1. So the amplitude of the cosine graph is a 1. So I'll start out as y equals 1 cosine. And I only see half a cycle between 0 and 2 pi. So this number right here is 1/2. And then you just write an x. So my goal is to fill in the amplitude and the frequency spot, and a phase shift if necessary. For a phase shift, I will need one of those for the sine graph. Normally, a sine graph should start at 0, 0. But do you see I hit my x-axis way over at pi instead? And also, instead of my normal sine graph like this one here, which goes up first, from this point I go down. So since I go down, instead of having a 1 sine x, it's going to be negative 1 sine. These numbers remain the same, so this will continue to be a 1/2 x. Now instead of starting at 0, 0, I started at pi. I shifted right pi. The way I say right pi is minus pi. Now I realize I'm going to go over the 10-minute mark here, but I want to do at least 2 more with you and leave you guys with the last one afterwards. So if I look at the next one I have, to me this looks more like a sine graph because it hits the y-axis at 0, 0. I see I get up to 2. So it's going to be y equals 2 sine. And then I have to count my cycles between 0 and 2 pi. I have 1, 2. So 2x. For my cosine graph should have started at the amplitude. It should have started right up at that 2. But it did not. It's over here instead. Now, where it shifted to exactly between 0 and pi over 2, which is pi over 4. So I'm going to have to say at some point it shifted to the right, pi over 4. So if I look at my new x, I started at a 2, cosine. Remember, your frequency number always stays the same. And I shifted to the right by pi over 4, so x minus pi over 4. I'm going to do one more with you guys, and then I'm going to leave you guys with that last one to try as well. So the skipped problems are the 2 that I skipped. For this one, let's see if I do the sine graph first. Sine graph should have started at 0, 0, but it did not. It shifted to the right by pi over 4. I can see I got up to 1, so it's going to be y equals 1 sine, and I see that I have, I'll show you a cosine cycle. There's one cycle right there, and I have another cycle right here in black. So I see I have 2 cycles, so 1 sine 2x. And my other one, if I want to make a cosine graph instead, I see I started down at -1. Since I started at the negative amplitude instead, it's going to be -1 cosine. This number remains the same at a 2. And x. I forgot to say this. Back up at my sine graph for a second. Remember my phase shift? My phase shift was to the right pi over 4, so minus pi over 4. One thing I do want to mention is that I could have more than one equation work. You might pick a different equation than I do, and it still might be totally correct. So I want you to try the one that we skipped at the top and this last blue picture here as well.